All right. Hello, everyone, and welcome to the stream. Hope everybody is doing well. We are going to pick up kind of where we left off last time, although I've done a little bit of tinkering offline, so we're going to kind of go over some of that stuff. But we've got some decisions to make in terms of direction we want to take this animation system. So we're going to talk about that. But before we do, I do want to just take a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Lazaron, followed by our partners, Gorillas Inc., Magatsub, and Matt Ostgard, those are the highest tiers of subscription over on YouTube memberships, Patreon, as well as Twitch subscriptions, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your continued support. It helps me cover the costs of things like hosting fees, software licenses, things of that nature, just regular costs associated with running the channel. So thank you all very much for that. It is greatly appreciated. And of course, I appreciate each and every one of you, the viewers, whether you're joining us here live on the YouTube side or on the Twitch side, or if you're catching the VOD after the fact. Thank you guys so much for being here. Without you guys, this channel and this project would not exist. So thank you very much for being here. Dr. Elliott, you are indeed first. How's it going? Spiro, good to see you as well. You are second. Yep, Dr. Elliott beat you to it. Frozen Shadow, good to see you as well. Hope you're doing all right. Okay, so on the roster tonight, we are going to talk about a couple of things. So we've got our import process, which I sort of did a little bit of research offline on how to load that up the way that we actually need it. And so I kind of rewrote a lot of that logic, but I didn't throw out the old logic because we need parts of it. So we're going to talk about that. And then I also kind of restarted the animation system because I wasn't really loving how it was coming together. So we're going to talk about that as well, because what we're going to do is we are going to take this animation system, as it were, and we're going to take the skeletal animation system that we started to scaffold, and we're going to combine them into a single system that is going to manage just essentially animated meshes, right? And then we're going to have a single asset type for both. So right here, you can see I've got like an animation asset. That is going to be also going away. And we're going to be switching from that to just having a single asset that kind of contains both. One thing I was considering doing was to have a sort of separate skeletal asset that would contain the bones and animations for a particular mesh, but not the actual mesh itself. And then the mesh itself could then be in a separate file, and you link those two together. The problem with that is that the mesh itself still requires references to bone information, and generally you'd want to do that when you want to use the same skeleton for more than one mesh, but I don't think we're going to do that this time around. I think I'm going to keep it simple. We're going to keep that stuff combined from now. And in the future, if we want to split that out, we can go ahead and split it out. But I think I'm going to reduce complexity here and just try to keep things as simple as possible. So with all of that said, we are going to be making some changes to the way that we're kind of handling all of this, right? Because that's one of the things that we're doing on this channel, is to sort of try things to see what works and what doesn't work. And adjust accordingly. So we have a couple things here. Let me just open up this guy here. So under our systems, currently we have an animation system and a K animation system, right? And the K animation system is sort of the one that I was experimenting with off camera. And I think I'm going to use sort of a combination of these two guys plus the skinned mesh system. So if we think about the requirements that we really have. We are still going to model this after the static mesh system. So as a reminder of how that system works, because I want this to work similar in terms of API. We essentially have, your standard initialize shutdown, and then you have your static mesh instance acquire, and then instance acquire from package, right? And that just hooks into the asset system and loads thusly. And then you have, of course, your release, and then you've got all your functions to sort of work against it, right? And then, of course, you've got, the ability to generate render data and all that stuff. So I think I kind of want the new system to be modeled after this, but for what we're going to call animated meshes, right? And I know I've kind of gone back and forth on naming things and how we want to organize it, but I've done a lot of thinking offline, and I think that's probably the design we need to stick with. In addition to that, we also have some of the work that we've done in here, importing from Assemp. We've just kind of done it in the KAsset importer. And so we're going to need to take all of this out of here and get an actual importer set up, which will basically just be a separate sort of container that we can put that in. So we've got an audio import here that sits in a importer audio H and C file. Same with image imports, same with FNT imports, things of that nature. So we're going to kind of try to stick with this method of doing things. And we want to make this work the same way as importing an OBJ. So the other thing that these meshes have to deal with is materials, right? So it's kind of a little bit of a widespread issue, right? We have to extract all of the material information, set up Kohi materials, and then import those into actual Kohi materials, and then we also have to extract all of the mesh data, as well as all of the bone data, the hierarchy data, as well as all the animation keyframe data and that kind of stuff, right? The other decision that I've made is, for now, we are going to focus on single animations at a time. I was talking about doing some blending. I think we can add blending after the fact, but I just want to get sort of a single animation running for right now. So we're going to try and simplify this to get it working, at least get it working quickly, keep things simple, and then add on to it after that. So with that, probably the way that we're going to handle this is going to be very similar to how we handled OBJs, where we have like an OBJ to KSM, which is the Kohi static mesh. And so we just do the static mesh imports, and then we go ahead and we do the import of all of the materials that are defined there. This will kind of work the same way, right? The only difference being is we don't have to open a separate file to do it, right? So we'll have that. We won't have to write a separate, MTL, like an OBJ MTL to KMT. That's going to be one place where it differs. Let's see. So we don't have to do that. Okay. And then I've already got like a lot of the material stuff worked out in here. So I think we should actually be able to move a lot of this over, just straight over as is. So, okay. So let's talk for a second about our structures, right? And I probably need to rename some of these because I just kind of hastily named them. And we probably ought to make them a little bit more consistent at least. So this should be K animation asset, which I'm not 100% sure I want to actually even stick with that naming convention either. But essentially we have a few different things here. So we have, I guess we should probably start off with, we should probably start off with the animation, which actually we should probably start off with the animation asset, because this is actually probably going to be the place that we need to start, right? So this is kind of still assuming that we're going to keep animations separate from animated meshes. So we do have some things we need to add to this format. But the way that this works is it has a list of animations. It has a list of bones. It has a list of nodes. So nodes essentially give us the hierarchy internally, right? These animation nodes. They give us the local transform. They give us, here's the hierarchy of that, right? So we extract an assemp set of objects, right, into this structure here. And that is what we start to actually build out all of these other structures with. Did we just get we just got a raid. Boolean, thank you so much for raiding with a party of 22. Welcome, raiders. Thank you so much. What did you get up to on your stream? Let me just do a quick shout out. I don't know that I'm following you, so I'm going to do that right now. But what did you get up to on stream? There we go. Gave you a follow. Welcome, readers. So I will go ahead and give just a quick introduction as to what we're doing here. So let me see. Redoing all of my sprites, converting my game's grid from 16 to 16 to 17 by 17. Okay, yeah, I see where that makes sense. Finally finished. That's awesome. Well, yeah, I gave you a follow, and I will check you out the next time I happen to be online and see that you're on. I'll jump into your stream. So what we are working on here is something called the Kohi game engine. So it is a game engine that we are writing from scratch in C using Vulkan as our initial rendering backend. I say initial rendering backend because the engine has been designed to support multiple rendering backends, and we are going to support DirectX and Metal in the future. It is cross-platform compatible, so it runs on Windows, Linux, and macOS desktop environments. We do have other platforms planned, but those are the big three that we support right now. This whole series was designed to be sort of an educational exercise. It's and resource rather. It's sort of the resource that I wish that I had when I was learning how to do this stuff. And so it started off as a tutorial series, and we morphed formats over time, and we eventually landed here on the live stream format that we see here. And yeah, so with that, we also have, so this is the main website that you're looking at here. It's sort of the portal that has all of the things, all the links and whatnot. For some reason, my YouTube, the bot isn't working on the YouTube side again, so I'll just paste that there. And I do see there's comments over on the YouTube side. I will get to you guys in just a second. So we do simulcast to YouTube and Twitch. And let's see. So the engine itself is open source, free and open source on GitHub. So it is Apache 2.0 license, which means if you want to use it, you can use it for whatever you wish, whether it is personal or commercial, does not matter. There will never be any software licensing fees or royalties of any kind ever. This is an educational thing. I don't believe in paywalling, that kind of stuff. That being said, the engine is very much in early days. So it is not what I would call production ready yet. We are still very much building it. And the plan for this is to actually build out the engine, and we're going to build a game, which we've already started planning and actually building. So we're going to kind of build those things in tandem. And yeah, so we will build that game all the way up to a release on Steam. So that is the ultimate plan there. Let's see, am I missing anything? I've got a couple of other links here, like to our Discord. We've got about 1,000 people on there. I don't have any sponsors or anything, so yeah, the only thing is sort of the Patreon link there if you're interested in that. But I think that's just about it, right? I think I covered everything. The only thing that I should cover, in addition to that, is this is a way to make a game engine. It showcases a way, not the only way. Sometimes not even the right way to make a game engine. We do a lot of experimentation and trial and error on here to see what works and what doesn't, and we do a deep dive into those things that don't work when it happens. So yeah, that is the not so quick but still dirty intro. Let's see. How do you keep your code? How do you keep your debug code separated from the production release code? Is it all ifs, pound ifs? Yes, it's all if defs. And likely we'll have more of those in the future, more levels of it. Right now we just have a debug build and a release build. Does it have any documentation getting started stuff? Not yet. I'm holding off on writing a lot of that stuff because this is very fluid in development right now. Writing documentation at this point wouldn't serve much of a purpose because there's still so many moving parts, right? Things are getting changed, refactored, moved around. We are through developing. So I should mention also that by developing a game with this as we're making the engine, that's sort of how we're testing it, right? So you don't really want to spend a lot of time writing documentation for things that you know are going to change before you actually wind up releasing. So most of the documentation for this is probably not going to be written until we actually hit a point of being pretty close to a 1.0 release. We do have some API documentation here, which is just auto-built every time I check code into main, or every time I merge code into main. This is auto-built. So it is just Doxygen auto-generated stuff. So if you're curious about any of this kind of stuff, there is some things in here that you can look at. Let me just find, I guess I could look at, there is documentation here that's auto-generated. So we do have that. But again, this stuff is changing too much to document it just yet. Like what you're doing here, gotta run, get some stuff done, but I'll lurk. Thank you for the lurk. I appreciate it. Hope the rest of the stream is wonderful. Appreciate that. Yeah, we're actually just getting started for the night, so I appreciate that. Yeah, and thank you again for the raid. High five. Wait, the high flies. Wow, my dyslexia kicked in hard there. First time chatter, welcome.
You dingus.
Can I ask you why you chose the name Kohi? No, it means coffee in Japanese. But what made you go, that's it? Honestly, I love coffee. I'm always drinking it. I'm not drinking it now. But yeah, I have several cups of coffee a day. I just love coffee, and I love, you can see I've got Japanese bookmarks up here, right? So, I love things, Japanese, and I loved Japanese coffee when I went to Japan. And so I was just like, yeah, you know what? That's what I'm going to call it. And I just kind of went with it, and that was about it. Yep. Kohi was the #1 PvP server in Minecraft, where I was #1 on it for years, so it's a very nostalgic name. That's funny. Yeah, I actually, I ran into that a couple of times while I was Googling Kohi. In early days, I was like, oh yeah, it's a Minecraft thing, but I didn't really think there'd be much overlap there. So, yeah, I wasn't really too concerned about it. But yeah. Programming is the art of converting coffee into code. Yes, absolutely. In fact, I think, let me pull this up real quick. I think that's my literal, yeah. Yeah, so on X, my description right there converts caffeine into code. It's funny you said that. All right, over on the YouTube side, let's see. Which font am I using? What font is this? This is Meslo LGS is the font name. I had to think about it for a second. And it's the nerd font variety, so I can get all of these symbols over here. Do you have a runtime reflection system or thinking about adding one? I've thought a couple of times about adding one, but I don't know how much value there'd be. So I don't have one at the moment, but I have thought about adding one. Goldfish the Bounty Hunter, how's it going? Singy, good to see you as well. Hope you're doing well. Gandev, good to see you as well. Body is a machine that turns caffeine into seg faults. Yeah, we do that a lot here too. We do a thing here called dingus-oriented programming, where I screw up code on stream live for you guys to see. It's a new type of programming, you know. You have object-oriented programming, but then you have dingus-oriented programming. You know, it's a different paradigm. Cool to see people making a game engine. I'm actually into. You're making a programming language, graphics API, physics, and game engine between you and your friend. Jeez, you must have a lot of time. That sounds awesome, though. I mean, yeah, that's admirable. I've thought about writing my own programming language, but I kind of want to finish what I'm working on eventually. I'm going to assume you're probably younger than I am. So, yeah. Once you get older, it's like, I don't have time to do that kind of stuff anymore. I want to release this game before I die, you know? Let's see. Wrote one to support an editor like Unreal Engine, but I'm still not sure as well if it's worth to have. Yeah, so we are eventually going to have an editor. My plan for an editor for this is going to be, I'm going to build it into the game code first. And then I'm going to, once we actually have one that's working, I'm going to extract sort of the components out of it that could be made generic and move those into a generic editor that maybe I include as an example plugin for the engine. Let's see. No, you're not a huge fan of C++, but what are your thoughts on Rust? So I've not done a lot with Rust. I spent a weekend on it at one point. I don't know. I don't really have a full qualification to speak too much on Rust. I do know that I don't think I would like fighting the borrow checker all the time. So yeah. But yeah, aside from that, that's opinion based. It's not really grounded in fact, right? So I've not used it enough to really have a qualified opinion on that. So unfortunately, that's the answer. Wonder if a TypeScript game engine would have good performance. Well, it's funny you mentioned that. Now, this is only 2D. Bear with me just one second. So, I literally actually have on my YouTube channel a TypeScript WebGL engine. Now, I wrote this 7 years ago, right? So it's dated at this point. And it was a 2D engine, right? Just to kind of show you how to stand one up. Like, this series did not go on very long at all. I think it was only, I forget how many episodes it was. But yeah, we did make, a very basic game with it, and it could be extended to 3D very easily. But yeah, you could totally do it. I wrote a number of game engines in TypeScript, so it's totally possible. Yep. Totally possible. And I just used raw WebGL for it. So Rust syntax is a pain. Yeah, Nivy I had that kind of same. I didn't like the way it, I look at Rust syntax and I'm just like, I'm not really a fan. I mean, I can get over that, but it's kind of the same way I feel about Zig, to be honest. Have you looked at Jai at all? I have not. One of the reasons, well, there's a few reasons, right? So there's Zig, there's Odin, there's Jai, right? Or all C alternatives, or at least they're punted as such. But the thing is, actually, hold on. So that's how many lines of code I have in in the game code, but in the engine itself, right now, some of these are kind of weird the way that they're classified here. But for all intents and purposes, you're looking at about 71,000 lines of code that I have written in C, right? And so, like, it's not worth it for me to actually switch to a new language at this point. Rust doesn't throw its syntax at you when you first start, but Zig, yeah. So, I mean, again, though, I haven't really given either of those, a fair shot or to have a fully qualified opinion. That's just sort of my surface level opinion. Because the one that interests me the most out of the three of them is actually Odin. But little Rust I've done, it feels very convoluted to the newcomer, which makes it less approachable, but the borrow checker has to see everything to be able to verify. So even though you think you aren't being unsafe, the borrow checker doesn't know. So you have to do something that beats around the bush to make it happy. Yeah, and see, that's the kind of crap I just don't want to deal with, right? Just let me write the code. That's generally where I'm coming from, right? I don't want to have to be fighting the compiler all the time just to write my code. I just want to write the code. As a language designer, I like hearing gripes, etc. about things. Odin is my number one personally. Jai is just much more game focused. The fact that Jenga FX is running Odin shows how good it is. Yeah, fair enough. Odin has one of the best laying docs, by the way. I haven't looked at it in depth, but I've heard it's very good. Fighting the compiler would drain me so quick. No, thank you. That's how I feel about it, right? I've got code to write. I don't need to be fighting the compiler. Like for a small pet project, fine, but like... Now, that'd be different if I wasn't doing this in my spare time, if I was doing this professionally, and there was a studio that, approached me with an offer, but they wrote everything in Rust, fine. I would write it in Rust and just deal with it, right? When push comes to shove, that's fine. And I'm not opposed to like learning it. Maybe I will do that, but like I just don't have an interest in doing it now because I've already got it's a bit of a sunk cost fallacy, I guess you could say, right? That's a thing for sure. Have you tried WebGPU? I have not. I started messing with it at a previous job, but then I wound up leaving that job before I got anywhere serious with it. So not really. My impression of it though is it's pretty much like metal. Can we send our repos to get your review on live? I unfortunately don't have the time to do that because I only get to stream a couple of hours a couple nights a week. So unfortunately, unless I had like dedicated streams for that, but like I don't see how I would do that and be able to move on or move this project forward. As it is, I have to code a lot offline just to keep things moving. Writing a compiler is as big of a project as an engine. Yes, 100%. How's it going, by the way, Raz? Good to see you. Yeah, writing a compiler is like one of those things that I've wanted to do. I've wanted to kind of write my own C compiler, but who has time for that? Not me. Not this guy. Terry Davis was a genius programmer. Yes. Yes, he absolutely was. He suffered from a lot of issues, unfortunately. But, yeah, very intelligent guy. Let's see. Odin is nice that it's like C with a couple of ease of use features and fun math types. Yeah, that's kind of that's what I got from it. But again, I might switch to it at some point if it's good enough, but like probably not for this project, right? All right. Terry Davis mentioned, yep, poggers. Yeah, I won't be writing this in Holy C. Can't be doing that. I don't have time for that either. Been scrapping and redoing your language, I'm assuming you're talking about over the last 2 months. Yep. That's the problem with it, right? And even Jonathan Blow has talked about Jai, and he's like, yeah, it's been I think it's been 8 years, 9 years that he's been working on that. Actually, didn't he start it in 2014? Or was it 2015? I can't remember. But it's been like a decade that he's been working on it, or close to a decade. Right? And he finally got like frustrated on some level with it, I guess. Because like, how long am I going to spend making this thing instead of making actual games? There was one interview with him that said that. I forget where it was, but yeah, that's the thing I don't want to fall into for sure. All right. So we have a K animation assets. So what I want to do is the structure we have with this now is the animation asset holds our animations, our bones, our nodes, which is for like hierarchy, transform, those kind of things. And then our global inverse transform, which is like, it's sort of like an internal offset, right? And so that wraps those. If we go to a K animation, the K animation itself contains information about a specific animation. So how long that animation is, how many ticks per second the animation plays at, the channel count, and then the number of channels. And if we go to anim channel, this contains a bunch of keys, right? So keyframes. So for positions, scales, and rotations. And these can be different counts, right? So these are keyframes for positions, scales, and rotations. And so we have those, and then those are just, if we go up here, all a keyframe is just a value and a timestamp as to how far into the animation it is, right? So we've got a vector 3 here, and we've got a quat. So the vector 3 is obviously used for position and scale, and the quat's used for rotation. So we have that. And then, let's see, we have the anim bone info. So the bone info, most of these things have a name, by the way. So we have the offset matrix, which is used to convert from mesh space to bone space, right? So it's kind of to get that offset. And then this is what actually gives us a index into the bones array, right? So that's how we tie those two things together. And then, of course, we have the anim node, which is this guy here. So this has a local transform, a parent index, a child count, and children. And this array is just a array of indices into other nodes within this array, right? So we have all of those different structures that are going to represent an animation asset. Now, if we're going to combine that with a, say, animated mesh asset, right? So we want to store that data as well. Then we're going to need to combine some of that data into here, right? So we're going to have let me think, what was it? Vertex, skin vertex 3D. And that's going to be vertices, right? And we'll have a U32 vertex count. Oh, you know what? We can't even actually view that yet, actually. There's one more level we're going to need. We're going to need to actually split this up by mesh, because actually each one of these assets can have not only a bunch of bones in them and various nodes and whatnot, but it can also have multiple meshes, right? So you can actually have multiple meshes within a single object. And then each one of those will have a material assigned to it, which we'll also have to figure out. So there's a lot going on here. So I guess, should I move this stuff first and rename the animation system before we go any further? because we kind of want this to handle both things. I guess let's type def. We're going to do a K-skin mesh. And this is going to have skin vertex 3D. Right, vertices. We'll do U32 vertex count. We'll also do a K name, and we'll give it a name. And then we'll also have we'll also need a U32 index count. Keep hitting the wrong dingus key. All right. And then we'll have U32 indices, right? Why is this bleating? Type def K-skin mesh. Did I already declare that somewhere else? Oh. That's going to be in the skin mesh system, I'll bet. Let me look at that and see if there's anything that we need to keep out of this. Yeah, there is some stuff that I am going to need. Okay. Let's actually call this something a little bit different then. Let's call this actually, it's really just a skin, right? It's not, we don't have to call it like a skin mesh. We could just call it just a skin, right? I guess. Because the skin vertex 3D actually contains bone IDs and weights, which is what we're going to need to correspond with the other bones and stuff that go with this, right? So if we have this, we call that K-skin. And then we have here skins, right? And then U32 skin count. So if we have that, then we can have a relationship between the bone indices that are in the vertices here and these bones here. Let me see. Let me catch up on chat here. Let's see. It's because I've made better proofs for a better system. We've finalized this design, though. I'm happy with it. Okay, cool. If you ever go public with it, feel free to toss it up on the Discord. Potham, how's it going, by the way? Good to see you. Switch back to C from Odin after 2 years. While I enjoy Odin a lot, maybe even more than C, it needs another couple years before I consider switching back. Okay, so that was one of the things, that was another concern that I had with a lot of the languages that are out there, right, is maturity of it, right? Apotham, what are some of the issues that made you switch back? Because that, I feel like that would eventually happen to me too, once the newness of it wears off. No matter how you listen to, there's so much skepticism surrounding new programming languages. It seems like either people are just talking, passing off other people's opinions as their own, or everyone has suddenly become a strong conservative. In any case, opinions based on this can't be considered authoritative. Yeah, and that's why I always say, like, I don't have a qualified opinion on any of these languages because I haven't used them in depth enough to have a qualification there. So always make sure to preface it with that. Like, I feel like until you've used a language for at least a year on something major, you don't really have room to speak on it all that much, outside of personal preference. When I tell them this, they just tell me it's just their opinion. I don't have to listen to them, blah, blah. Turns out people are very fond of just sharing their opinions. Yeah, I mean, fair enough. Standard Pointer, how's it going? That's right, Spiro, you did give Odin a shot too. I remember that. You tried to get me onto Odin. You also tried that with Zig. But yeah, I mean, I couldn't justify switching a 70k line code base. Nah, it's not a big deal, Spiro. You were just passionate about it. You were excited about it, right? Like, I get that. I couldn't justify changing that large of a code base over to a language that I didn't know was definitely going to work for, what I needed it for. And my biggest issue there is like, my biggest fear with all of these new languages is, what if I hit a compiler bug or a language bug? Then I'm really screwed, right? That can potentially bring me to a halt, and I don't want that. And that was the main thing keeping me from it. Jeet, over on the YouTube side, hello, how's it going? Good to see you as well. Hope you're doing well. Okay. So we have this. I suppose what we could do we could keep a K material instance at this level too. Right, so we have one skin or one mesh, right, or animated mesh, whatever we want to call it, is going to have one material. And I think this is a fair grouping at this point to have. And this will help us when we go to generate the render data based off of that, right? So when we go to generate the render data, we will need a combination of the vertex data here, along with, now that I'm thinking about this, we not only need this, we also need the vertex buffer offsets and the vertex and index buffer offsets to be stored here as well. Which K-geometry technically does give us. Just trying to think if that is. We could technically use a K-geometry for this and eliminate some of this stuff. Maybe we should just do that. What do we have in here for geometry types? We do have skinned in here. Maybe we should do that. Instead of storing all this information here, maybe we just have a K-geometry. Right? Because that stores not only the vertex data itself, the vertex count, but also the vertex buffer offset, which we're going to need to draw it. So it's kind of that and all the matching index information. So maybe we should just use that, because I think that's what our static meshes do. And then a skin just becomes this. The difference being that, unlike our static meshes that just use a standard vertex 3D, this one's going to use skinned vertex 3Ds. I still don't know if I like the K-skin name. Like, that seems long. But it's a little bit more descriptive, I guess. Right? We could just do this. And so this K animation assets could technically just be renamed to K animated mesh asset. Which I think is acceptable. I can't think of any reason not to go this way. So this combines the two types of data that we're thinking of. And the way that we're going to work with this asset versus the way that a lot of other assets work is, instead of duplicating a lot of this data, right, we are just going to keep the asset active. So we're not going to basically unload the asset as soon as we are done uploading to the GPU, for example, because we will continue to query the animations, the bones, the nodes, and technically the meshes as well. And then in the animator for that, the animator takes a single asset, right, and holds a pointer for a current animation, which we might just convert this into an index instead. It holds the time and ticks, which is something that we load from the asset itself. And then this contains the actual final bone matrices. So these final bone matrices are the final bone matrices that get uploaded to the storage buffer that we set up. And these are what gets taken in by the shader, right? So those essentially, I don't know if we actually need to, well, I guess we could keep them for debug purposes. But essentially these would be recalculated every frame, right? So we would query all of our bone transforms, all of our keyframes, figure out what current keyframe we're on, and then recalculate these. And I actually have a lot of this logic figured out. So that is not really an issue. And then max bones is essentially going to be how many bones are in the asset, right? So it's just kind of a quick way for us to look that up. I might wind up getting rid of that and just look it up in the asset. Okay, so let's do, maybe we rename this to animated mesh animator. Seems kind of stupid. Do we do K animator? That seems a little bit too in specific. I swear, naming is always the hardest part of this stuff. Let's do, I guess, wait, K animated mesh animator, I guess. And so when it comes down to what we're actually going to store in the system, it's going to be these, right? So when we refer to, and actually this, I guess the asset could probably have a name, right? even though that's really just going to be for debug purposes. Actually, no, there's two other things I need to do. This should be asset name, and then package name. And then when we refer to an animated mesh, we'll have a separate K name for it, for the animator, right? So whenever we want to call into our API and we want to say, hey, we want to animate this, we want to make this animated mesh called this use an animation called this, right? And that would be essentially the way that would work. We probably are going to go with instances of this, just like we did with our static meshes, so that we don't have to duplicate all of this data internally, all of this asset data, right? Because really this asset data is just this can be reused for a bunch of things. Like none of the state of this, any of this stuff changes. But the animator essentially has all of the state, right? So the animator has a reference to the asset, queries the asset. And then it contains, the current animation state and all that stuff. K animation. The only thing, let me check. Yeah, so this is all read-only data. None of this actually needs to be written to. Okay. So we would essentially have a animator. I better write some of this down. So one animator equals one animated mesh instance state. Right? So for every animated mesh instance you have one of those. So the animated mesh assets you can really think of as this is the base animated mesh queried by all animators instances. Right, just to kind of stick with our nomenclature that we use throughout the engine. Okay. What was I going to do? I don't think I wound up actually using that, did I? No. Oh yes, I did. Down here. Okay. So K animated mesh, I think that is good. Anim node is going to have to be renamed as well. So we'll rename that to K animated mesh node. K animated mesh node. The bone info should probably be renamed as well. Let's just make this, oops. Let's just make this consistent. Whoops, what did I do there? There we go. So this is going to be renamed to animated mesh bone. And actually, I'm going to do away with the term info. It's just going to be a bone. So K animated mesh bone. The animation is fine. That's maybe we should swap that though. Let me check something real quick because we actually have a second. We have a second K animation that I want to make sure that we're not renaming. Okay. All right, so I want to rename this, and we're going to do K animated mesh animation. Now I realize a lot of these types are kind of verbose, right? But most of these types are not going to be used outside the animation system, so I'm not really too worried about it. But it's enough where I want to be kind of specific in the way that I name this stuff. So, oops, I did it again. So we're going to do K animated mesh channel. There we go. Do I really need to rename these? I'm not going to rename these two. These I think I'm just going to leave as is. I don't even need, they probably don't even need to be public, as it were, but there you have it. Okay, so this is what our consolidated data is going to look like. We have an idea of how that needs to look when we query it. So I want to take a look at our system that we started scaffolding on the last stream, because we want to pull from this the valid bits of stuff we want to keep. So actually, you know what? I'm actually just going to grab all of this and I'm going to move it over here, and we're just going to rename it as needed. So this is going to be, are we still calling this the K animation system? That doesn't sit right with me. We should probably call it the animated mesh system, and then we'll get rid of the skinned mesh system. So let's do animated. Let's do K animated mesh system. Right. We'll do that. Obviously, we need to set up some properties to actually represent what the config for that should look like. And then we have the animation system state. So I'm going to go out on a limb here, and I'm going to declare this at this level so that we don't have to have so many. If we want to just query the data from somewhere, we can just query the data, right? So we'll do a struct, and I'm going to say K animated mesh system state. K animated mesh system state. Okay. And to this, we are going to have, let's see, a couple of things. So we need the base data, which we've already set as the asset, right? And then we need the animator data, which we're saying is the instances, right? So we need, let's actually do K animated mesh asset. And we'll do base meshes, we'll call it, right? And this is going to be a D array, so that we don't have to maintain a separate count. And so that's going to represent the base. And then we're also going to have the K animated mesh animator. And this one is going to be a double array. And this is going to be I guess we'll just say instances. Right? And so this is also going to be a D array. So first dimension matches base meshes, right? So it'll be indexed by base mesh and then indexed by base mesh ID. Then indexed by instance ID, right? So every time we create one of these, we will also push to this, and we'll create a new array for instances. This is a similar pattern that we've done elsewhere, and that's kind of the way that that's going to be organized. And then everything that we do down here having to do with a particular animated mesh is going to flow sort of through that, right? So in this case, we're going to need one more thing. Actually, I should probably put this... I guess I could put it... Let's put it here. We want a struct, and we're going to call this a k-animated mesh instance. And this is going to... It's going to create, or it's going to contain, rather... going to contain two things. It's going to contain a U16 base mesh and a U16 instance. So whenever we request a new instance of an animated mesh, we're going to say what mesh we want to use. That'll become the base mesh. So this will index into this array. And it'll also be the index to the first dimension of this array. And then the instance of it will have a separate ID, and that will be the second index into, or the index into the second dimension of the instances array, right? And then whenever we do an operation, we pass this struct that contains both of these things. And that's just kind of the way that that works. We could also do... We could represent this by a single number, a single U32 that maybe we just OR together. I wonder if we should do that. That way we're not having to worry about all this stuff. We could just worry about essentially passing a number around. Makes it a little trickier to debug, though. I'm going to leave it this way for now. We've type defed it, so if I want to change it later, I can always do that, and the change will be completely opaque to the rest of the system. Let's see. I'm doing well, by the way, Jeet. Thank you for asking. Appreciate that. Switching to a different language is more than just learning how the language works. Also how it's written idiomatically. You wouldn't want to write a functional language like you would write a procedural language. Exactly. Yep. 100%. Backend Tower, how's it going? Welcome. You are new here. Welcome aboard. Is this the same engine you've been working on for the past 4 years? Yes, it is. Yeah, so we've made pretty decent headway. We're adding an animation system now. And we're kind of feeling out what that structure is going to look like. We've kind of come up with a few different ideas. I think this design that I'm going with now, I think is going to be the best one. So that's what we're going with, at least for now. Let me see. There's nothing major I found wrong with Odin, just got tired of dealing with an evolving language, which is why after Odin gets its 1.0 release, I would strongly consider using it again. Yeah, that was the other thing that worried me too. And I remember, like, a great example of that is I used TypeScript when it was still in alpha. Because the place that I worked had a deal with Microsoft so that we had early access to it. And man, did that language change a lot from when it was first introduced, right? It's barely recognizable now if you use TypeScript when it first came out. It's almost a completely different language. At least to me, feels that way. So yeah, like I definitely get that. That's that would be a barrier to me adopting a new language for sure. That's amazing. I'm following the older videos and I'm wondering, is there a point where you start over that you recommend? What do you mean? Like if you were to, I guess what do you mean by that question? Would you mind clarifying that a little bit? Like what do you mean by start over? Like refactoring wise? No, there's not really a, because we've done several refactoring streaks, right? Which is not really what this is. This is like designing a new system, right? Coming up with a new system sort of on the fly. But we've done a few of them, but I also kind of walk through as to why, right? So I don't know. That's part of the thing about it sort of being a live sort of ad hoc format is like we don't have necessarily clean cut points where it could be like, well, you can just pick up from here and none of the context before it matters, because it's not really the way it works, right? Because you'll see some systems come and go, and we discuss why those systems come and go along the way, and then how that sort of makes us land on the next system that sort of replaces it. We haven't done that too many times, but there's a few big ones that I can think of, but yeah, I wish I had a better answer there, but I don't, unfortunately. It's just kind of the nature of the beast and how this is unfolding, right? Let's see. There hasn't been any changes in Odin for a long time. I think the last change in syntax was more than a year ago, and Bill said that the language is done. Only the spec has to be written to reach 1.0. Oh, okay. How is it on like compiler bugs and stuff? Are people still finding like lots of either holes in the spec or compiler bugs or things that would maybe hold you up in doing a sizable project? I haven't been able to keep up with it, admittedly. First time chatter, welcome, by the way. And again, it's not that I don't want to try Odin, it's just I've got the sunk cost fallacy going on here too. So, all right, so let's do K animated mesh system state. So that's going to be that, and then K animated mesh system config. Wait, what did I call it? K animated. Oh, what a dingus. I didn't type config up here. I was like, why isn't that showing up? It's not going to show up in IntelliSense if you didn't call it that initially, you dungus. All right. Mesh system config. There we go. All right, so everything here is going to have K animated mesh system state. So we can do, we want to keep the updates. We want to keep the prepare frame for now. The timescale thing we want to keep. All right, so animation create and destroy. These are we're probably not going to keep those. And then animation track play. I'm not 100% sure that I'm going to keep these either, at least as they are, right? Because we don't have anything called tracks anymore. We have animations. So we should probably also talk about how we're going to structure that, but we'll get to that in a minute. We do need frame data, so let's go ahead and include that. That's fine. Okay, so these don't need to be exported. Their symbols don't need to be exported because they are only going to be used by the engine. However, everything down here does. So, when we talk about animation creates, oh, you know what? We should probably rename this before we go any further. So this should be the K animated mesh system. right? Let's do that. Now, for system-wide calls, that nomenclature makes sense. But for animation creates, let's rename this. We're going to call this kAnimated mesh instance. Do we want to say get instance? How did I do that in the... Instance acquire. Yeah. In fact, you know what? I'm gonna do this just as a reference, so I can think my way through it. So instead of k static mesh instance, right, we're gonna have k animated mesh instance for both of those. This is going to be k animated mesh instance, right? We can get rid of those. Whoops. There we go. Okay, so this instead is going to be kAnimated mesh system state. I'm gonna have to change that again here. This will be kAnimated mesh instance. Okay. So, let's see, the acquire. So these are asynchronous asset loads, is the other thing we have to keep in mind. So we have the ability to provide callbacks for this, right? So the instance acquire, we'll just do animated mesh loaded, right? We'll just do same here, animated mesh loaded. So they each can have a callback and a context that gets passed along with them, right? We'll have to hook up those function pointers or declare those function pointer types in just a second. Okay, so the way that this works, just as a refresher, is the instance acquire says, okay, we're looking for an asset with this name. If it's already loaded, then cool. All we need to do is grab a new instance of it, which is essentially creating another one of these animator things up here. And we can immediately essentially call this callback, passing along whatever context was passed from the caller. The from package is the same thing, except it declares a package name as well. So this defaults to the default application package, which would be the game package, as it were. Versus this one, you can actually specify a different package if you created a different package, or you're using maybe a third-party package. It's just kind of got that kind of support in mind. So I guess we need the PFN definitions first. So let's go to static mesh system, and I'm just going to go here, and I'm going to grab this, and I'm actually going to put this right here. No, I'm not. I'm going to put it up here with all the other type defs. I was going to co-locate it, but All right, so this is going to be kAnimated mesh instance, and this is going to be animated mesh loaded. All right, so that's what the callback is going to look like there. It's just going to include that instance, which will allow us to very easily look that up from the state, along with any context, right? So we've got that. The mesh instance release, of course, is going to do the opposite. So essentially, it's going to destroy the instance. And then if the reference counter for that particular mesh reaches 0, it's also going to unload the internal mesh asset. It also releases held material instances, which again, material instances kind of work the same way. So you've got that sort of base and internal that includes all of the actual base data that gets queried from all the other stuff. And then you have that renderable instance of it. So we've got that. And then we just need to figure out a way how we want to say that we want to play a particular animation or pause, stop, seek percent, whatever, against a particular mesh instances animation set. So there's a couple ways we could do that. The easiest way I can think of API-wise is probably by name. We could also have some sort of animation ID internally that we could query for. So yeah, maybe that would be the way to do it. So maybe we have something like, maybe we do, and actually we wouldn't even have to do, before we actually do, let me think about this for a second. So we would do KAPI, and we could do kname. Wait, kname? How would we want to query for that information? If we said, I have an animated mesh, give me all of the, we could say, give me all the names of the animations. And then you could just pick one out of there and go for it. Or maybe you already know them in code, which you probably should, and you could just do it without having to query for it. Or if we go by ID, then we need to say, okay, well, now I need a list of animation names and their IDs so that you can then use that ID to trigger the animation. I feel like kname is just easier to deal with. I'm gonna go that route for now. We can always change it later. I don't want to overthink it. So we're going to have a kname array, and we're going to say kanimated mesh. And it's not going to be an instance. This is actually going to query the base mesh because it'll know. So we're going to do query animations. So we'll do struct kanimation kanimated mesh system states. And then we'll do U16 base mesh. And then we also are going to need a U32 pointer to store out count. Right? So note dynamic array needs to be freed by caller. Returns. We can make our comments nicer once we figure out the rest of the API, right? So this is kind of a specific, or I should say a higher level query for just the base mesh. When we're talking about wanting to like play or pause or stop a particular animation, that has to be against an instance. So in this case, we'll do KAPI void kanimated mesh instance play. Should it be animation play? No, I think we just do play. I think it's inferred by the arguments. So we'll do struct kanimated mesh system state. And then we'll do here a K animated mesh instance. And we'll do a K name animation name. Because then we don't have to worry about like keeping a list of indices internally and trying to look that stuff up. I mean, we'll still have to look it up, but like you're not going to be calling play every single frame for a particular thing. Although you might be calling this one every single frame. Okay, I'm gonna have to think about that one for a minute. All right, so let's work out the other ones. So we have play, pause, stop, seek. Right, so this is going to be pause, stop, seek. A couple of these actually have some more arguments, right? So does this animation loop? Or do we want to play this? Do we want to loop when we play this, right? When we do stop, let's see. Actually, the only other one we need F32 time for seek. What time do we want to seek to? So this is a range of 0 to total animation track time. We'll keep that comment. And then actually, you know what I'm going to do? I'm just going to move these up here. Okay. Oh, you know what? I need instance here. There we go. Struct K animated mesh system state. And then this was K animated mesh instance. And then we don't have, let's see. I guess we do need animation name, don't we? I wonder if we should pass animation for all of these, or that's kind of poop now that I think about it. We should actually have this instead. We'll have animation set, right? Maybe we'll make loop a separate property. Right? And then all we have to do is it's just going to play the current animation. Or stop or seek. Yeah, that makes a lot more sense. Right, so you set what animation you want to use, and then it just does these operations against the current animation. That makes a lot more sense to me. And then I guess you could even do this. You could do instance loop set, right? And then you could have
You dingus.
BH loop. Thank you for all the follows, by the way. I appreciate that. Let me see. My 2D game engine was about 30,000. I assume you mean lines. And with how bad of a mess that ended up being towards the end, I never found a compiler bug. Okay, well that's commendable then. Lines of code. Yep, okay. That's commendable then, Apotham. Nice theme, thank you. Appreciate that. In fact, if you're interested in that, there's a link to my NeoVim config. Let's see. What am I looking for? I mean, I guess I'm not really looking for anything, right? I'm just trying to define how the API should look, and I think we've got it, right? We don't actually need any of this stuff anymore. Get rid of that. Yeah, I think this is a much better design, and we can get rid of the other two systems and just go with this system. And then this system will also handle the loading of the assets, so we don't have to worry about that either. I like it. Trying to think to myself here if there's any holes in this design, but I don't think that there are. Okay. So let's grab all of this, and we have a lot of stuff written in K animation system C already, and so we'll have to sort of refactor a little bit of this code to match what our new system is expecting, and we'll have to make some calls into all of this, but that's not going to be too big of a deal, I don't think. So most of the prototyping I've done in here was all just internal static functions. And so, we can just kind of move around our code as needed, and we don't really have to stick to sort of any API except for these things that we've defined here. So let's do boy, this one is a decently long one here. I suppose I could have written a little bit faster of a macro, but whatever. I don't have to repeat it that many times. All right. Oops. And I don't need these export symbols in here. Okay. So, essentially, I guess we should probably start with initialize, right? Because a lot of this other stuff is going to, you know what, let me fix these errors first, actually. There's not that many of them. So instead of K animation asset, this is going to be K animated mesh asset. I think it's mostly around renames that seem to have failed. I'll come back for that other one. Okay, the rest of these are all animator, so for some reason the rename did not get these. Okay, cool. All right, so most of the rest of the stuff is just warnings from stuff that we'll be fixing, like non-return types. Let's see. Ginger Bill, the language creator of Odin, works for company Jenga Effects, creates Embergen, which is written in Odin, is a very large project. Obviously, that doesn't mean it's free of bugs, but I would say the language at this point is pretty stable. Yeah, I did know about that. I have heard about that. I guess I mean, you know, in things like this, right? A game engine that eventually is going to be, you know, a quarter to 500,000 lines of code by the time we're done. I don't know how big Jenga Effects is, but sorry, Embergen. Orshi, how's it going? Good to see you. Love C. Let's see. From what I heard, Jai and Odin should be improvements of C. Maybe I'll try Odin. Jonathan won't let me use his language. Yeah, that's the other thing that, like, do I want to be beholden to somebody that, you know, that might not let me use it? I don't know. What if he gets bored and doesn't want to maintain it anymore also? People be sleeping on Zig. Yeah, I mean, Zig looked pretty cool to me. The comp time thing specifically had my attention. I don't know, though. Like, a lot of the syntax is weird to me, so maybe that's just because I'm a boomer and I've been writing C for so long, but supposedly we'll be entering public beta in the next year or so. Interested in trying it, but also a little worried that its metaprogramming will create a mess, but who knows? Yeah, that's a valid concern as well. Yeah. Definitely a valid concern. A concern that I have as well. But also, public beta isn't open source, right? So, like, if I were to hit an issue with it, or maybe find some sort of bug with it, like, how long is that going to take to get resolved, right? And I don't necessarily know that I'd want to use a beta language for something like this that I intend to go to production with. So, yeah, it's just those are the reservations I have about it, right? It's not to say that the language isn't good or anything like that. It's just I have reservations about it. Let's see. Let me catch up on the YouTube side. Some places might have been changed in the Vulkan API over the years, so the code that you've written back then might not interact with the current system. Yeah, so, I mean, pretty much everything has changed from the early videos, right? There's a few systems that haven't changed, but, like, especially around rendering, as we added and improved stuff, yeah, there's been lots of stuff that's changed. Do you think AI will be able to do this one day? Well, I mean, one day is kind of nebulous, right? So I can't really answer that question, because maybe 500 years in the future, if we haven't blown ourselves up by then, maybe. But, you know, that's impossible to say. Anytime soon? No. What kind of animation system are you building? Just a basic one for now. So we're starting super simple. It's just an animated mesh system that, you know, like a skeletal animation mesh system that I guess you could say. It's just going to play a single animation at a time. I'm going to be adding in blended support afterwards, but I've decided not to do that in the initial version of it, just so we can get something running. But yeah, eventually we'll have, like, blended animations and stuff like that too. Yeah, it's just super simple, right? I don't know if that answers the question that you're asking, but if you want more detail, feel free to ask. Is that Gudetama? Do I have one, like, in view somewhere? Maybe it was. I know I do. I know I do have a few of them. Do I have one up there? I don't think so. I know I have some around, but I don't know if I have one in view of the camera. Unless I'm missing something. Oh, on my shirt. Oh my god. On my shirt. I forgot what shirt I'm wearing. Technically no. So this is a design from a company called Tea Turtle. So it's Gudetama-esque, but it's not officially Gudetama as far as I'm aware. It kind of reminds me of Gudetama though. But yeah, Tea Turtle has all kinds of hilarious shirt designs, and so I wear their stuff all the time. Yeah, I'm always forgetting like what shirt I'm wearing. Like I'll be wearing like one of my funny shirts and I'll go into like Publix or something, or the supermarket, whatever you want to call it. And, somebody will laugh at my shirt and I have to do this to see what shirt I'm wearing because I honestly don't remember. I barely remember what I ate for breakfast most days. Okay. So wrote a fairly complex game, so it should be a competent language, like as options on many programming subjects. Yeah, I would agree too. I mean, I assume you mean opinions. Yes, I have seen that he's done that for sure. But even he has run into like compiler bugs in the middle of stream and stuff. I've seen that happen a couple of times, which is to be expected, right? But again, like it's closed source at the moment. So like if he just decided he didn't want to do it anymore and he's just like, you know what, I'm deleting all this stuff, like there's no recourse, you're stuck. Or if he decides that he wants to change the licensing or the way that it can be used, like, totally up to him to do. Like he can do that. I don't know that he will. I doubt it. But if he wanted to, he could. And so that makes it kind of tricky, right? There's lots of things that I consider before just trying something like that. Not to mention, of course, again, the sunk cost fallacy that I have going on here with, 70K lines of code that I have to convert. Not particularly worth it in my case. I love that your name over on YouTube is just poop. That's deeply hilarious to me. That's super funny. Any tips for doing an engine that uses different things for each platform? DirectX for Windows, Metal for macOS, Vulkan for Linux. So theoretically, we could actually do that with this engine now. I just don't have the other backends written. So the way that this engine is designed, I'm going to give a really quick overview of this. Is we have this sort of renderer backend interface. Let me make sure I'm not behind my head here. We have this renderer backend interface here that essentially contains a bunch of function pointers, right? And these are sort of generic function pointers in terms of how the renderer should work. So everything from window creation to starting a command list to submitting and presenting, viewport, scissor, some of the other things you might expect, like depth enabled, depth right enabled. All of these functions here all have a Vulkan implementation, for example, right? So creation of shaders, creation of textures, modifying those, binding them, et cetera, right? So that we have all of this stuff that what we call our renderer front end interacts with, right? So this is our, we have a renderer front end and a renderer back end. The back end is obviously like Vulkan or eventually Metal or Direct3D. Those are the ones that I have planned for this engine. So the way that I handle this is the back end is actually loaded as a plugin, and it is a freestanding library, right? So like on Windows, that'd be a DLL. And the application decides which one it wants to use. You could also set up some code to do that depending on the platform that you're using to just load the appropriate DLL and use that, for example, or SO or dilib, whatever whatever platform you're on. And it essentially loads function pointers for all of these things depending on what DLL gets loaded, for lack of a better term, right? And so the advantage to doing this is that the front end of your renderer that interacts with the rest of the engine does not care what renderer backend you're using, and you could just swap them out. This isn't designed quite to do that on the fly. You will have to restart to do that, to swap from one to another. But if you're just talking about targeting different things on different platforms, this is going to be the way to go. To just have those different things either built into a external library that you load in dynamically, and you link against dynamically, or you could if-def them out if you wanted to go that route, although that seems kind of crappy. But you could do that as a proof of concept as well. So there's a bunch of ways to approach it. Hope that makes sense on a high level, at least. Are you going to build an editor? Yes, we are going to build an editor. The first editor that we're going to build is going to be actually part of the game code. And then once we have a decent amount of tooling set up, we're going to extract the parts of that could be used generically into a freestanding editor application that you can use. Is this primarily C89? What standard are you on? This is primarily C99, actually. I have swapped over to C17 for some debugging stuff. But when I do a release build, it'll be C99. Let's see. Curious, what opinion do you have about const for everything, especially function parameters? I always found it to be more of a pain than any benefit you're supposed to get from it. So I have switched on this a couple of times off and on over the years. I think when you're finalizing your public interfaces for things, it's fine to use const. You'll notice I don't do it a lot here. While I'm laying something out and I'm trying to figure out how that's going to work, I don't generally start off with const everywhere. I kind of get the system working, and then eventually at some point when I've got a little bit of time, I'll do a const correctness pass, right? But yeah, because sometimes it can get in the way. And then if you've got multiple layers of something where you thought it was going to be const, but then you get 6 layers deep, and you're like, oh yeah, I actually have to write to that state all the way down here. I could argue that that's a design issue, A, but B, it would suck because then you have to unconst all the way up, right? And it just kind of gets in the way. Not to mention that you could just cast it away, right? So my opinion on that has kind of shifted back and forth over the years. I don't really have a landing spot on it because I used to go like ham with it, const everything that didn't absolutely need to be written to, and I've since switched away from that because it gets in the way. You have no doubt that Jai is a competent language. Same, I agree. Just worried that when the language is released, the ecosystem will be polluted with libraries where the users have used the metaprogramming to create their own dialects of the language. When you expose the user to the AST, you run into these problems. Yeah, that's a valid concern, actually. It's a really good point. Interesting take. Thank you for the answer. Awesome. Glad it helped. C99 is goated. Yeah, it's my favorite for sure. Okay. So I guess I'll just take just a couple more seconds here just to kind of bang out a little bit more of this. I'm just going to bat that to the side. Let's see. Mesh system config. I think I needed, what did I did need, I was just thinking about this a minute ago. I did need a default state for something. What was it in here? Oh, I need to know from configuration what the default application package name is. So we can actually get rid of this and do kname default application package name. That's going to come into play here in a second. I also need to take this and put it into the mesh system state as well. So all we're going to do is take a copy of it, but nevertheless, it is something that we need to know. And that is for when we go to acquire an instance. If we use this one that does not specify a package, it's going to use that default as application package name versus one that is specified here. See, the only thing that really gets used for. Okay, so what we'll do is we'll say memory requirements is going to be equal to size of k animated mesh system state. And then if we don't have memory, we'll go ahead and return true, right? Because it's not technically a failure. So this works like a lot of our other systems, where you call it twice. You call it once to get the memory requirement, and then the engine provides or gives us some memory that we need for the state, and then you call it again, passing that state. So this is going to be k animated mesh system state equals memory, right? And then we can let me clear these annoying highlights. The first thing we'll do is we'll do states default application package name equals config default application package name. And then obviously we'll just return true all the way down here. If we get all the way to the end of this, we know we've been successful. The other thing is states base meshes needs to be darray creates. And that is going to be, what was that? That type, right? So we have that, and then we have states instances, which are that two-dimensional array of animators. So that's going to be a darray creates animated mesh animator, and that's going to be pointers, right? So again, these two arrays align with one another, and they they are both indexed by the base mesh ID, and then instances within each one of those has an array of instances of that base mesh asset. Okay. And I think that is actually all that's in the state for now. We probably are going to have other bits of state that we're going to add to that, but for right now, that's all we need. And so for the shutdown, I guess the best way to handle this is probably going to wind up being, we're going to actually have to let me think about this. So to do release all base meshes, including, well, yeah, including unload from GPU. And then we're going to have we need to release all instances. That should probably come first. If I can hit the right key here. So we need to release all instances, release all meshes, and then the engine will go ahead and free the actual state for us. So we just need to make sure that we do that. I am not going to fill this in right now because I don't want to have to refactor that if we wind up changing the structure of it, right? So I'm just going to leave that as is for right now. The update is going to be a to-do. Basically what that's going to be is iterates all mesh instances and update their final bone matrices. We probably ought to have an active flag. Some way to mark meshes active and not active, right? Because there may be situations where we don't need to perform those updates for a certain amount of frames. And then maybe skip forward or something like that. Like maybe it's not visible. Maybe we don't need to be animating it, right? Something, I'm not sure. We'll have to figure that out. But we may need some sort of active flag to say whether or not we should perform the updates. But for right now, we're just going to do brute force, update them all, and then eventually, we'll optimize it once we actually get that working. Okay, animated system, mesh system frame prepare. So this is going to be simply upload all of the meshes, or I guess it would be mesh instance final bone matrices to the SSBO. Right, so that's going to be a to-do there. Timescale. This was one of those things. Ooh, this shouldn't be, well, timescale is a tricky thing because technically speaking, we can have a global timescale and we can also have an instance timescale. So timescale is essentially how far away from real time are we playing an animation, right? So a timescale of 1 would be real time. We're playing it at its normal rate. A timescale of 0.5 would be we're playing it at half speed. Timescale of 2 would be we're playing it at double speed. And so I could see there being a use for that globally, right? So making all animated meshes play at that same speed, but also you might only want to scale some of those as well. So actually there's two timescales we need here. So we actually probably need to put this here, and instead of system, we're going to say instance timescale set, right? And we'll do this. Right? So that's an important distinction to have, is, sort of what level we are setting that at. All right. So let's see. I guess we should probably have in our state, we should probably have F32 global time scale is what we'll call it. In our initialize, we will do state global time scale equals 1.0f. Right, so we'll set that default. I don't think that needs to be a configurable thing. I think if we need it in game code, we can just call it. So we'll do here let's see, where was that? Here. Wait, that's the instance one. This one. This one we could just do state global timescale equals timescale. Simple enough. I suppose I should probably put some assertions on some of these things as well, particularly the functions that get exported, which that would start with this one. So we can do k assert debug. I'm going to do a debug one. So we want to make sure that state exists, right? And I'm using a k assert debug because I won't need to do that in a release build. We only need to do that in like a debug build to make sure that we're not being stupid. Okay. So instance acquisition is going to be the next thing that we go through. Querying the animations. So yeah, I guess this is going to be the stuff that we're going to handle on the next stream. I think handling all of this stuff is just going to be setting state within the mesh instance, so I'm not really too worried about that. And actually, the update for this, we have a lot of this figured out too. So at least I think on the surface, we'll have to see. But I think I've got a lot of that worked out in the other functions further up in this file. So we'll have to hit that up potentially on the next stream. All right. So that is going to do it for me tonight. I'm going to I have to get up and go to work early in the morning. So let me find somebody to raid. And I want to thank you guys again for all the interaction. It was a very active chat tonight. I appreciate it. I appreciate you guys being here. I appreciate all the new follows. If you haven't followed yet, I would greatly appreciate a follow, either on the YouTube side or the Twitch side. I am trying to grow the channel and reach more people, and hopefully get more people to want to narrate more low-level stuff like this, because I think having competition in the space is super valuable. And so I'm looking to spread that message and hopefully a little bit of inspiration along the way. Okay, I'm going to have to filter this a little bit. Try and find something that's relatively related. I see who I'm going to raid if I don't find something that's more related, but... Give me just a quick second here. All right. I think I know who I'm going to go with. Yeah. Okay. So we are going to go... We're going to raid Jitspo. He's making a pretty cool retro FPS. And he's using Godot in this case, but he's got some pretty cool mechanics that he's put into the game. So definitely be sure to ask him about that. That's pretty much going to do it for me tonight. Thank you guys again so much for being here. I appreciate you guys. And I will catch you guys on the next stream tomorrow night. All right.